So in this video, I will explain decoder and, and the counter circuit basically. So first, the main questions is how to make decoder or what is a decoder. So basically, a decoder has two input like 2 cross 4 decoder and 4 output. Okay, so suppose the my input is A and B and output is I naught, I1, I2, I3. So basically this is the output and this is the input, and here is the my enable signal. So when decoder is enable, so this AB is just like a combination, like you said 2 bit input like uh, suppose here is A and here is B. So 0, both can be 0, 1 0 1 1, here 1 here 0, and both can be 1. So four combination we can see, and according to this four combination we choose the which output will uh, like go to 1 or like that. So in this time my I naught will be on, I1, I2, and I3, so on. So the by this way we choose AB input and we got the output I naught, I1, I2, I3. And suppose one questions is come like we want to make 4 cross 16 decoder by 2 cross 4, then how we can do. So let's see. So by using 2 cross 4 and 2 cross 4 to 4 cross 16. So here is 1 2 cross 4, 1 2 cross 4, 1 2 cross 4, and 1 2 cross 4. So 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, and input input. Here is A, here is B, A B, A B, A B. Another four input, sorry, two input and four output, and these signal goes to the enable signal of these goes to the enable signal of these goes to the enable signal of these, and last one like enable signal like go to here, and this is C and D. So when CD has four combination like previous one 0 0 0 1 1 0 1 1. Okay, so when 0 0 0 0, so if I name it correctly, I0, I1, I2, I3 like that, to I4 to I15. Dot, 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 dot. So when CD equal to 0 0, so my these output will select. So if this output will select, then it goes to here, and this provide a enable signal. And if it is enable signal, then my if my AB is 0 0, like AB also be such that like 0 0 0 1 1 0 1 1. So if my AB is 0, then my I not output will be selected. So here if you put any LED or anything, so that's glow, or that's the like giving you one in one output. If suppose my CD equal to 0 0 again and my AB equal to 1 1, so then which output will be select? Obviously this output will be select. So which one is my MSB here? So here is my MSB. I took like this CD and AB. So basically you can change in, you can change, and you can write like if you can do here A B and here C and D, then your is like that. So AB is 0 0, so you choose this one. And if CD equal to CD depends on you, like if CD equal to 1, then it goes to I3. If suppose AB equal to your 1 1 and CD equal to 0 0, then which output will be shown? So AB equal to 1 1, so this line goes to here and the provide enable signal this decoder. And now your AB, sorry, here like CD everything is CD. So here CD. So if your CD, now I look at CD is 0 0. If CD is 0 0, then here your output will be I12 will be selected. Okay, so this is like we make a decoder from 2 cross 4, and this is totally a 4 cross 16 decoder. And now we'll make a decoder. So here the 4 2 cross 4 decoder. But who will change your input? Like suppose you give the A and B, but who will change your input so that your output will be selected? So that your output will be selected. So AB, like 0 0. If like the switching operation done by which? So this is my question. So this will be actually done by counter, like counter circuit. What is counter circuit? Basically, suppose mod 3 counter. Okay, so this is mod 3 counter. So mod 3 counter, like that it goes to 0 1 and 2. Then when it comes to the 3, it's reset and go to the 0. So how we make mod 3 counter? Okay, let's see. So here the output, because it's 3, so 3 maximum mod 3, so it goes to the 0 to 2, 0 1 2, and this will be reset. So this is not shown here. So 0 2, so maximum I think maximum 2 bit required. Basically 2 to the power 2 equal to 4. So obviously 3 is below to less than 4. So 2 bit required. So how to make? Let's see. So 2 bit. So one flip flop is here and another flip flop is here. So basically I say this is my Q0 and this is my Q1. And here is the like simple, we take the T flip flop, because in this case when the clock is required, so we need to toggle. That's why the counter circuit will be work. And this is my clock, and T is always 1. Here T is always 1. And this output Q0 directly goes to here. If it is directly goes to here, then what do we see? That this is more down counter or up counter. This is not Q not. Let's me correct. This is Q1 bar. Okay. So here is flip flop number 0 and flip flop number if 0 if 1. So now we see that what is this flip flop, like what is this counter, down counter or up counter? Okay, so initially my I assume Q0 and Q1. Initially my Q0 and Q1 is 0 and 0. Then what would be now? If my clock is, here it is clock circuit. So if my clock I give to here, and my one is already like my in flip flop T flip flop, my input is 1. So Q naught, here it is will be better. So my Q naught will be 0 to 1. If 0 to 1, then this circuit will be trigger or not. Like if 0 clock like 0 and then 1, so my circuit will be trigger. So this circuit will be trigger, so that the here also 1. And if this one input of the T flip flop 1, then what happen? My output will be toggle. So whatever the in Q1, then it's toggle. So it's have 0 before, so now toggle. Okay, now circuit is again the clock is 1 to 0. So here no toggle, because if 1 to 0, if my clock is goes 1 to 0, then this Q naught goes to 1 to 0, so that here no clock, so that my flip flop 1 will be hold position, so 1 0. If 0 to 1, then what happened? If my q naught g goes to 0 to 1, then clock comes and it's trigger the flip flop 1, and it's toggle now. So what happened? In now 1 goes to 0, and if 1 to 0, then it's no clock, so my q naught output is 0, and also it's 0, it's hold. So we see the output which actually toggle, and the circuit is basically sorry, the q naught and q1 is like down counter. So initially gives 0 0, but it's like goes to 3, then 2, then 1, and then 0. So it's a toggle, like it's a down counter, and it's always we use a T flip flop for making counter. We can also use JK. So in JK, we need to put JK into mode of T, like J and K are sorted. So this is another part. Now every circuit I goes through this by using T flip flop, like making counter. And in previous circuit, like we then what if, like how to make a up counter? Let's see. So here is T flip flop. So T input is 1. So let's give the name flip flop 0 and flip flop 1. Here is the clock that goes in, and this my output that goes to in, and here I make negative clock. Okay, and here is my output. Let's see. So negative clock, it's a negative clock. So when it is my Q0 bar, Q0, Q1, and Q1 bar. Let's check the circuit. So here is my Q0, here is my Q1, and here I write clock. So initially everything is 0 0. So now if my clock is 1, clock is 1, this is clock. So if my clock is 1, then Q0 goes to 1. But my circuit will be this flip flop. Where it's working when my Q naught goes to 1 to 0. So 0 to 1, there will no triggering, no clock, because it's a negative edge triggering circuit. So when it goes to 1 to 0, then it's work. When my q naught goes to 0 to 1, that time it's not work. Okay, so that time it's not work, so it's 0 1. Q1, whatever the previous value that's hold in Q1, that's hold again, the 0 will be hold, and again my clock is 0 1 to 0. So now 1 to 0, so the 1 to 0 means clock will be there, clock will be clock goes to the flip flop 1, so it's triggered. If it's triggered, then q1, what will be the q1 now goes to 0 to 1, because it's a toggle mode, so we give 1 here. So if it is toggle, then in previous value it was 0, and now it's 1, so 1 0. Now my clock 1, then if my clock 1, then it's again toggle, it's toggle to 1. But 0 to 1, there is no clock in flip flop 1. So the 1 is hold, And if again the 0 clock, then what happen? 1 to 0. There is no clock, means here 1 to 0. But if we, sorry, these actually these no, actually these every time these are behaving as clock. So we don't need to put clock 0 or 1 like that, because when the clock is come here, that's time only 0 to 1, 1 to 0, 0 to 1, and 1 to 0 will goes like that. Okay, so this is the, actually I did little bit mistake. So basically this part will not be happen. So because in every time when comes the clock is positive, that time q naught is triggered at 0 to 1 and 1 to 0, 0 to 1 and 1 to 0. That's the way q naught got the output. Like in q naught we'll see the output like this way. when when we got positive clock in flip flop 0, in flip flop 0 when we got positive clock, that times only goes q naught goes like that, 0 to 1, 1 to 0, and 0 to 1, again 1 to 0. So in this time, if 1 to 0, if my q naught is 1 to 0 goes, then then this clock will be activate, means this flip flop will be active activate, and the output of q1 will 1 to 0, because we got the clock. So the toggle mode will be happen. And what is the previous output of q1? That is 1, and now it will be changed to 0. So we see that this is nothing but 0, 1, 2, 3, and again 0. So it's a like up counter. You can see it will increase 1, 1, 1 like that. So it is a like 2-bit up counter. So if my circuit, like suppose the in we previous we generate a decoder. This is 2 cross 4 decoder, and we make a counter circuit. So this is my counter circuit, so that output output q naught, suppose this is my q naught, this is a, and q1 this is b. And we see that how the up counter or down counter is happened. So it will work like this, and a clock, just only give to the clock, and that circuit will be work. And we get output one by one, like I naught, I1, I2, I3, like that. If suppose some output we don't require, like I3, I don't require, so what we did, we give here like and get, like it's a, we make a up counter and get, and here is reset, so that when comes to 1 1, both are 1. So both are 1, what happened, this circuit goes to the reset position. Okay. And initially I think it's take to a little bit time, so that uh, asynchronous, this is asynchronous reset. So in when q naught and q1 not shows the output, so it's directly reset. So that's 1 1 position will never come. Maybe it's seems like that this goes to 1 1, so it looks like it's goes to the output. So 2 cross 4 decoder my shows to the output I3. But in asynchronous the behavior is, if 1 1 is come, so it's immediately reset, and again it's in this position we will never see, this position 1 1 we never see. So my output 0 0 0 1 and 1 0 only. So like that. So this is my counter, and one of the trick that I will learn from Himanshu Agarwal. So that is like my flip flop is I make flip flop like 2 cross 4 like mod 3 or mod 4 counter, so that, so here's the trick, like how I decided that the this is mod down counter or up counter. So to flip flop basically. Okay, so clock, clock, and clock, clock, input, 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 input. Okay, so here is my q bar, let's assume q naught, q1, q1 bar. So if my if we take the clock from q naught and it's not a negative edge triggering flip flop, then this is like here it is positive and here it is positive. So if both are positive, then it's down counter. Okay. If here I take positive and here I give the negative edge clock, like this flip flop will trigger at negative edge. Okay. So what happened? This is basically up counter. Here positive, but here negative. So by seeing this like positive negative, I can comment up counter. And here I will take the from negative, here q bar, and this is my positive edge trigger. This flip flop, this flip flop is my flip flop one is my positive edge trigger. So I will take here from negative clock, like negative output from flip flop 0, and here it is positive. So what happened, this negative and this positive, it will up counter. So basically in here, if the sign is changes, then it up counter. If sign is not changes, like both are same, then it's down counter. If here it is negative, it's q bar, and here it's the clock is like my negative clock, negative edge trigger flip flop, like flip flop one is my negative edge trigger, then it's down counter because both are negative, here are negative and here negative also, so it is down counter. Down counter. So this the trick I learned from Himanshu Agarwal. So he's a good teacher also. And this is the counter part basically. So and and also some kind of mixed type of uh like you can't comment that this is a up counter or down counter. So that kind of type of counter is like hybrid counter, you can say. So here three flip flop. So three flip flop is like one goes to one, everything is positive edge trigger, and here it take the negative. So here it is like it is my q not, here my q1 bar, and here it is q2. So this is like here it is positive, here it is positive, but here it is negative, here it is positive. So this is like random behavior. So your circuit might be changes, like it's not like up counter or down counter. That time you can just go through the clock and check the q0, q1, and q2, and then you can write the result according to the clock. So this is basically hybrid counter. And suppose I want to make a mod 12 down counter, then how to make mod 12 down counter? So mod 12 down counter, so basically uh, like 1 1 1 to goes to 12. So one trick. So 15 plus 1, that is 16, minus 12, that is 4. So goes to the 4, goes to 4, basically the 0 1 0 0. But when reset, reset is my like 3 0 0 1 1. When this will be happened, then it reset, like preset, and it goes to again this part, like it key 1 1. So how to make the circuit, let's check. So previously I give the shortcut, so now I use that shortcut. So here is my flip flop 0, if 0. Here is my flip flop 1. Here is my flip flop 2, and here is my flip flop 3. Why I take flip flop like 4 flip flop? Because the maximum number in 3 bit is that is 7, number 7. So you can only make a mod 8 counter. So it's not possible to make a mod 12 counter by 3. So at least required 4 flip flops so that you can make a mod 12 counter. Okay, so down counter. So you can down counter by using this way. So first I take the 1, everything is 1, it's a T flip flop, so everything is T T T. So here 1 and here 1. Now here's the output Q3, here Q2, and here is Q1, and here is Q0. So if I take the input from Q0 to this uh, flip flop 1 clock, flip flop 1 clock I take from Q0, then it's positive, like both are positive, then it's down counter. If both are positive, suppose like this, both are positive, so it's down counter. And if we take from negative, then it should be negative, otherwise it's not a down counter. So here negative and here negative, so it will behave as a down counter. So why we not take from here to here? So it's just you can take, it's I will show in this picture that I will also take the clock from Q2 bar also for my next flip flop 3. So I need to mm, put a negative clock here, a negative edge trigger flip flop we need to require, so that uh, my circuit will behave as a down counter. And here is my clock at flip flop 0, so it behaves as a down counter. And so just realize the circuit that it behaves or not down counter. So initially it is 1 1 1 because I already assume that my Q0 Q1 Q2 already 1 1 1 position. And now check the circuit. Sorry, actually it's better to take Q0 Q1 like this way, like Q3 Q2 Q1 and Q0. So if my Q not equal to 1 1, so already there. If it is 0 1 to 0, then my this circuit will be on or off, flip flop 1. So we'll check. So if my Q not previously 1, like previously 1, and my circuit will be now off, it's positive edge triggering, flip flop 1 is positive edge triggering, then how it will be on? So it's not on, so that these are hold. 1 to 1, so no clock, 1 to 1 no clock, Q3 1 to 1 no clock, so it's hold. All other output Q1 to Q3 will be hold at hold position. Now 0 to 1, so clock is there, clock there. So we'll see the Q1. So Q1, what happened? Q1, we see that if Q1, here Q1 in Q1, it goes to its previous value was 1. So now it's toggle. Its toggle means now value is 0. So 1 to 0, there are any clock? No, 1 to 0, there are no clock. So my, because 1 to 0, you can see 1 here, so 1, and this 0. So 1 to 0 means clock like this. And your in this picture, my flip flop 2 is positive edge triggering, so it can't work. So it's hold the value. And so again 1 to 0, no clock, so hold the value. Now 0 to 1, clock again, so it's toggle. 0 to 1, so when 0 to 1, then it's toggle. So 1 to 0, 1 to 0. So if 1 to 0, 1, so Q2 1, Q2 1 to 0 means my Q2 bar equal to 0 to 1. If 0 to 1 goes to the negative edge clock, so it's a positive edge, so my flip flop 3 will not work. Okay, even it is like to from negative side, but it is negative. So if my Q2 goes from 1 to 0, then my Q2 bar goes to 0 to 1, and this clock look like 0 to 1, and it's a negative edge triggering flip flop. So here no trigger, so just the same value previous. So I hope this part will be understandable. And at the time, at the time, so it's a down counter, you can see easily, you can check also. 1 0, so 1 to 0, there will be no clock, hold. So 0 to 1 clock, 0 to 1 clock, then 1 to 0, 1 to 0, there will be no clock, and hold. If 1 to 0, there will be no clock, hold. So now 0 to 1 clock, 0 to 1 clock, 0 to 1 clock. If it is got a clock, so now it goes to 1 to 0. Why it goes to 1 to 0? Because let's see, if my Q2 goes to here, Q2 goes to 0 to 1, so my Q2 bar goes to 1 to 0. So if Q2 goes to 1 to 0, so it's look like this. And my flip flop 3 working as a negative edge flip flop, so here got the negative edge flip flop, negative edge triggering. So my flip flop 3 will be now triggered, so it goes to 1 to 0. So now go to the circuit just like that. 0 1 1 0 1 1, then 0, then 1, and 1 to 0, 0 1, 0 0, 0 to 1, 0 to 1, 0 0, and here 0 1 0 0, and here 0, sorry, not 0, here 1 0 0 0 0 0 0 0. So ultimately comes to 0. But one thing I think, uh, here we need a mod 12 counter, so we count the mod 12. So here 1 2 3 4 5 6, 7, 8, 9, 10, 11, 12. So I already told that here my circuit goes to 4, like 4, but it will be preset at when comes to the 3, like 0, 0, 1, 1. So it will preset. So as it is asynchronous counter, asynchronous means the clock is dependent on the previous output, like not previous, like dependent on the previous flip flop. So like my clock signal are not at the same time in each flip flop. So that's why it's a asynchronous. If asynchronous, then what will be the reset type or preset type? That is when 0011. So it goes to this bit, like 0011 flip flop goes to this bit, but immediately this will be reset, or like if according to our need. So this will be preset and this goes to like 111 again. So when it comes to the, so basically one short trick, that is my Q3, we take Q3 and Q2 AND gate, and these provide to preset preset of every flip flop, preset of every flip flop. So if my pay, and here also, so this is my output goes to every clock. This is preset. Preset means every flip flop again goes to 111. So now this concept, I hope, clear. And if I and encounter like some other topic are also be there, but as of now the counter most of the part is clear.